Okay guys, today's topic, which is actually a two-day topic, is literal equations. And that is basically an equation that deals with more than one variable. Okay, so when you have more than one unknown, you're not solving and getting an answer. You're basically getting the variable that you want to solve for, so to speak. You're getting it by itself. The most common time you'll do this in Algebra 1 is when you need to solve for y. So you may not know x or y, all right, but you can solve for y to get it in this form that we like. All right, so the first part of the notes are going to be examples of doing that. All right, now the rules that we've learned still apply, and those are distribute on each side if needed, combine like terms on each side if needed, use opposite math to move all variable terms to one side, and then use opposite math to isolate the variable. Now, you're rarely going to need the first two steps, but you're going to be doing a lot of this. It gets a little challenging, or it may stretch you when you're doing the math rules, even though it's not a number, it's just a variable. Okay, so I'm going to go ahead. This is actually, you're going to be seeing this form a lot this year. This is called standard form of a linear equation. The form that we prefer, it's more friendly because it's easy to graph and it gives us some good information. That is slope-intercept form. That's the one that we've already been talking about. Okay, when you have slope-intercept form, you know the slope. It's the coefficient in front of the x. And you know the y-intercept, it's the number off by itself. This standard form, it has one feature that's good, but there's not much good about it, honestly. So if we have standard form, we very often just convert it to this. So the way this reads is you have a number in front of your x plus a number with your y equals c. All right? And the basic thing you do with that is the same opposite math steps we talk about. So let's say I had something like this. I have an a number times my x plus some b number times my y equals c. I want to get y by himself. I still do the same steps. I told the story about y. This is y's house. He has a party. He's got a couple of friends over, okay? His best friend, and then this other guy, okay? He gets rid of the friends according to PEMDAS in reverse. Okay? The add subtract friend leaves first. The multiply divide friend leaves second. And you could even literally look at it and say the one who's closest to the y leaves last. You could call him the best friend. So this is being multiplied. That leaves second. Whatever's being added or subtracted leaves first. So this ax term would become minus ax on both sides. All right. So then I have c minus ax. And what do I have left over here? Just y and his best friend. And this is multiplied. What do? Opposite math is divide. Divide both sides by that. Now, the thing about literal equations is you're going to end up with something like that as your answer. Okay? Now, remember, these are actual numbers. They can be any number in front. And you might be able to divide sometimes and simplify, but this, it could be an ugly answer that's correct. Now, we're going to do 4 examples. Okay, you can pause the video in between, study it if you want, whatever you need to do, and then you'll have 4 of these on your own on the homework. But there's also other literal equations that we'll talk about on this video before you get there. So 2x plus y equals 7. This is in standard form. I make my wall. Here's y. He doesn't even have a best friend. There's no number here except an invisible 1. You get rid of this guy. Opposite of adding 2x, or in other words, opposite of a positive 2x. Let me zoom in for you, sorry. Opposite of a positive 2x would be a negative 2x on both sides. These two x's cancel. It's gone. What do I have left over here? Just y. What do I have left over here? 7 minus 2x. Or if you want to start realizing that you're dealing with slope-intercept form, you could even write it on purpose to match this. It's totally okay either way, honestly. I could write 7 minus 2x, or I could recognize negative 2x plus 7, the same two things just written this way. Then I could easily say, oh, my m number, which we'll start calling slope soon, is negative 2. My b number, which we call right now our starting value, and we'll learn more about that, is right here. It's 7. That's how you do it. All right, let that soak in. Let's do another one. Number 3 says 4x plus 2y equals 8. I make my wall. I find y. I'm solving for y. Now, here's the interesting thing about this. You could solve for x. You can solve for any variable that you need to at the time. But for all of these, we're going to solve for y. So I look at y. 2 is his best friend. They're being multiplied. I do not take care of the 2 first. I take care of whatever's being added or subtracted. That's the 4x term. He's positive. They're combined through addition. The opposite math would be negative 4x on both sides. All right, that cancels. Over here, I just have 2y. And over here, I have 8 minus 4x, which this time I'll just write in order in case this confused you. I'm just going to write it the way it is. 8 minus 4x. I'm not done. Last time I didn't have a number to divide off of, but this time I do. So this time I get rid of the 2 by doing opposite math. Dividing by 2 would be the opposite of multiplying by 2. Now this is a little interesting. Different teachers do it different ways. You're dividing the entire side by 2 here. Okay, not just like one part. If you're doing this whole side divided by 2, you're doing this entire side divided by 2. Some teachers put a big line and show the whole thing's divided by 2. Some teachers could do the exact same problem, and I'm just going to, there's my wall still, and they would show each term or each number dividing by 2. You get the exact same result either way. If I do it this way, I have 2 math problems, even though I only have 1 2 on the bottom. It's 8 divided by 2 is 4. Negative 4 divided by 2 is negative 2. So I'll end up with 4 minus 2x. Same thing here. It's a little easier visually if you like this better. 8 divided by 2 is 4. And negative 4 divided by 2 is negative 2. So I get negative 2x. So either way you decide to do it, let me zoom out a little bit so you can see everything. Either way you decide to do it, you're going to get y equals 4 minus 2x. And once again, if you want to write it in terms of mx plus b, you could just flip that around. That little subtract is part of the 2 minus 2x. And since this 4 is positive, there's no negatives with him, it would be plus 4. Either of these examples is appropriate and correct. Okay? Get in the habit of recognizing they are the same thing. So there's 2. We're going to do 2 more. And then we have some notes on the back. All right, so this one, we have 4x minus y equals 6. Okay, now this is a little sneaky. There's no number here in front of the y, but there is actually, you can consider there to be a negative 1 here because of that minus y. All right, so there is a number we have to divide at the end. So I have y. His best friend is the negative 1, and we're going to leave that alone for now. The guy we get rid of is the 4x. He is currently positive. Opposite math for this would be negative 4x on both sides. Now every time when I write this step, you notice I don't write this right below the 6 because they cannot combine. They are not like terms. Okay? On all the problems I've done, I always wrote it over here to the side. If there were some x terms here, I would combine. But there's no terms. I can't combine this at all. All right. I'm going to go ahead and cancel that. I'm left with negative 1y. Over here, I'm just going to write what I see. 6 minus 4x. Okay, my last step is to divide off this coefficient. Both sides divide by negative 1. And you can do it whichever way you want. You can do the long line across the whole thing, or you can do a line under each term. It's fine either way. It's fine either way. I usually do this just because it's less writing. But you have to understand, and there's a teacher I used to work with, she would do it this way, and she taught her students, because she was a girl, I guess, and she liked hearts. She said, draw a nice little heart to remind yourself that there's 2 problems there. I just think she liked to draw hearts, but I don't know. I don't know. It worked for some of her students, though. So that's another option. So since I'm in purple, I'll go purple here. So that cancels. Y is by itself now. 6 divided by negative 1, it flips the sign to negative 6. Negative 4x divided by negative 1 flips that sign to positive 4x. So that's the answer, unless, of course, you want to write it with mx plus b form, which would be y equals 4x, I put him in front, minus 6. The negative can now be read as a subtraction sign right there. Okay, one more. I'll zoom out so you can kind of see that and keep writing it down while I start the other one. We have 6x minus 3y equals negative 24. Okay, so I'm just going to rewrite it because I got a lot of busyness up here. Try to give you guys a break and space it a little bit. Okay, so 6x minus 3y equals negative 24. Okay, make your wall if you wish. Here is the term I want to get by itself. The y. Who's his best friend? The negative 3. They are multiplied. I always say you and the best friend, the y and the best friend are tight. They're close. They are together like that, and that is multiplication, right? Whatever works. Remember, we're doing opposite PEMDAS. I'll write it down here again. That's why we're not getting rid of the negative 3 first. We're getting rid of this term first, whatever's that kind of math. This happens second because we're doing opposite. We're going that way. So I'm getting rid of the 6x. He becomes minus 6x on both sides. And once again, I do not write them up and down from each other. They are not like terms. All right? So this cancels out. He's gone. I have negative 3y still, but this is gone. These guys I write side by side. Okay. Last step is to get rid of the best friend. See ya. He kicks him out. Opposite of multiplying by negative 3 is dividing by negative 3. This time I won't do the cutesy heart. I'll just show it this way. Remember, either way is totally fine. You're showing that you're dividing everything on this side by the negative 3. That's all you're doing. Okay? That cancels. I end up with y by itself. Okay? 24 divided by negative 3 is positive 8. Negative 6 divided by negative 3 is positive 2. And that guy has x attached. So that's how you do it. All right, we're going to move on. Not all literal equations they even have x and y. Some of them do. Here's one that does have x and y, but it gives you a little word problem situation. So this was the definition I gave you earlier. It's an equation that involves 2 or more variables. But a formula is an equation that it's defining the relationship between different quantities. They may not have any numbers. It may be all letters. Okay, here's a quick example. Area is equal to length times width. You can solve that for any of the three. Right now it is solved for A because A is isolated. You could easily solve for L or W. If I want L, you kick W out. Divide both sides by W. That cancels, and the formula for length then becomes area divided by width, and that's the true formula for length of a rectangle, right? You could have just as easily started with the formula. You want the width isolated, so you kick out the length. Divide both sides by length. Boom. Now width is equal to area divided by length. Okay, it's a little weird. I know students always have trouble with this because it's like all alphabet and no numbers, right? But it's the exact same math steps you've been doing for, 5 weeks now. So you can do it. Okay, let's do this one. The equation 10x plus 5y equals 80, where x is the number of pizzas. So this is pizzas. Y is the number of sandwiches. I'm just going to put SAN just as abbreviation. They want us to solve it for y. Well, we've already done that a couple of times. We can do that. So real quick, 10x plus 5y equals 80. Make my wall. Let me zoom in for you guys. Okay. I want y by himself. I have two dudes I'm kicking out. Here's the best friend. Okay, he can stick around a little bit longer. This guy leaves now. Opposite of a positive 10x or a 10x being added is subtracting. Cancel out. Over here I have 5y. Over here I have 80 minus 10x. Now get rid of that 5. Dividing. Again, you can do the little heart if you want. Jump, jump. There you go. This cancels. We have y equals, you do 80 divided by 5, which 80 divided by 5, 16. Sorry, I didn't have that in my head immediately. Minus 10x, 10 divided by 5 is 2, but it's going to be negative 2, right? 2x. So we solve for y. Let's now use that to answer the question. They have a couple of questions here. How many sandwiches can you buy if you buy 3 pizzas? Well, now here's the pizzas, and sandwiches is by itself. That's why we did it. You put 3 right here. Okay, you input that value. Minus 2 times 3. Okay, PEMDAS says to multiply first here, because we're doing forwards PEMDAS now. That's 6. 16 minus 6. You're going to have the ability to buy 10 sandwiches. How many if you buy 6 pizzas? The exact same process, but this time it's 2 times 6. So that's 12, and 16 minus 12 is going to be 4. So that's how you do that. Now, these are some formulas you learned back yesteryear, but we can actually solve for different variables. The circumference of a circle is found using the formula C equals 2 pi r, where C is the circumference and r is the radius of the circle. We want to solve it for r. Very easy. Okay, I'm going to write my equation. C equals 2 pi r, and this is very easy. I'm not just lying. It really is, because everything's just multiplied here, right? You can actually do it in one step. We want r by itself. Since everything's multiplied, you can divide these two guys off in one step. That all cancels. 2 pi divided by 2 pi is just 1. In other words, it's 1r, or r. So what is r equal to? It's equal to c divided by 2 pi. Now, there's other ways you would see that sometimes. Actually, I think I'm just going to leave it that way. I think that's probably fine. Later on, I'll show you some things where you just write this out as a fraction, but I think for that one, this is good. Number 5, what is the radius of the circle with a circumference of 64 feet? Okay, well, we know the circumference is 64 feet, which goes right here. Round to the nearest tenth. Okay, so it's going to be, here's my formula. Well, let me write it this way. R is equal to, I'm just flipping this around, R is equal to C over 2 pi. All right, so R is equal to 64 divided by 2 pi. And if you forgot, pi is a constant that's in your calculator. You could use 3.14, you could estimate, or you could use the pi button. There's the pi button right there. That way you don't have to estimate. See, it kind of estimates a little more, but that's a little more accurate, right? So, not a big deal to go either way. You could use the pi button of 3.14 right now, but I just want you to know you do have pi right here, the button on your calculator. So, we're going to do 64 divided by 2 pi. So, 64 divided by 2 pi. There you go. No, that's wrong. It didn't take it right. You see that? It said divided by 2 times pi. So I got to redo that. I figured that number was wrong. Let's do it this way. 64 divided by, and then I put parentheses, 2 pi. That'll do it correctly. All right, that's more like it. 10 point, etc., etc. But we want to round to the nearest tenth, so we'll do 10.2. All right. We have solved the equation 4 equals 2m minus 5n for m. Now we're getting into some meatier problems. There's not a direct pattern every time. It just depends on what math is there, right? We're going to solve it for m. So find the m. There he is. We're solving for that. That means everything else has to go over there. Okay, find m. There he is. He has a best friend of 2 being multiplied. He leaves last. This guy leaves first. Opposite math. Plus 5n plus 5n. Done? You cannot combine those. They are not like terms. So I'm going to write them side by side. 4 plus 5n equals 2m. Okay? Let me zoom in a little bit. So the opposite of multiplying by 2 would be to divide by 2. I'm dividing both entire sides by 2. You can do the little heart thing if you want or whatever. Let's go ahead and do the heart thing. All right. 4 divided by 2 is 2. Okay, you're not going to like this, but this is just where we live now. We're big boys and big girls in Algebra 1. We can do this, and we're okay with it. 4 divided by 2 is 2. What do I do with that? The answer is nothing. You just write it how you see it. When you have an improper fraction, unlike in middle school where they totally forbade you from ever leaving anything improper, we are improper in Algebra 1. This class is just straight up improper, all right? We're going to write it like that. If you can't divide it out and get a nice clean number, you don't make it a decimal. We prefer fractions, and we never use mixed numbers. Mixed numbers are a thing of the past, so don't even think of that. We're not talking about pizzas and whatnot anymore, okay? So 2 plus 5 halves times n equals m. That's the answer. That is the answer. All right? Now, what is the value of m when n is equal to -2? Let's do it. I'm going to write it again. This time I'll flip it around where m's on the left. 2 plus 5 halves. But I'm going to plug in my number for n, -2. Now, oops, sorry, I didn't realize you weren't seeing all that. Let me give you a second. When I zoom in, it's to help you see, but then when I move the paper around, I don't realize that you can't see what when I move it. Basically, we have 5 halves. You're dividing by 2 and you're multiplying by -2. So basically, these guys cancel, but the negative is still there. So you end up with -5. 2 plus a -5, or 2 minus 5. And when you combine those, you have m equals -3. Okay, I'll let that sit there for a minute. All right, let's move to number 8, 9, and 10. We're going to go through these quickly. I know the video is long, but I'm not here in class today, so this is what you get. Okay, we're going to solve this equation. -t equals r plus px for x. I always like to maybe put a box or something around the directions they're giving you so I can just see the equation. I don't want to get, when you look at all this stuff, it looks strange enough as it is, not counting all the extra stuff that's added on the end. So I try to isolate the equation from everything else so I can just focus on what's important. Okay, there's my equation, and I need to solve it for the x. So here's my x. He's the one that needs to get by himself. So I make my wall. In fact, I'm going to rewrite this just a little bit. Oop, that's not, I'm trying to do a cursive t. -t equals r plus px. Okay, so here is the x I need to get by himself, right here. This guy. So I make my wall. He's multiplying with a p, but he's only adding with the r. So the opposite of adding the r is subtracting r. All right, on both sides. That cancels. These are not like terms, so I just have -t minus r. Not too enjoyable, is it? But that's just how it is. And here we have px. Last step, we're dividing both sides by p. There. And this, believe it or not, is the answer. We have -t minus r over p equals x. And that's why students do not like literal equations, because they are not comfortable with that. Now I'll tell you, you're going to use literal equations regularly in chemistry, and very much so when you get into physics. So you'll find when you get good at them, literal equations are actually your best friend, because basically you need to solve for any given element of your equation. It's easy to do. You just manipulate the equation, and it can be any equation you need it to be. All right, just for time and for all the space element, let's not do 9. We've done plenty of those. I like 10 because it's a nice meaty problem. It's just interesting, right? Let's go ahead and do this one real quick. This is actually the formula for Celsius. So if you need to convert Fahrenheit to Celsius, this is the equation. Celsius degrees is equal to 5/9 times the quantity of Fahrenheit degrees minus 32. What if we want to solve it for Fahrenheit? Then we could have a Fahrenheit equation to plug in Celsius, right? Let's give it a shot. So we're going to use all of our math rules. Remember, the first rule is distribute on each side as needed. Okay, we do have distribution this time. I'm distributing 5/9 here and here. I'll use calculator for the heavy lifting with the 5/9 and the 32, right? 5/9 times F is 5/9 F. Okay, 5/9 times 32, just plug it right in. Control divide, 5/9 times 32. Gives me 160/9. And see, this is normal numbers for algebra. It's not a big deal anymore. Not like in middle school. 160 over 9. So, and it is negative because this is a positive times a negative. So, minus 160/9. So right now we have C equals this minus this. We have the best friend right here beside the F. So this guy leaves first. You do plus 160/9 on both sides. All right, cancel. So what do we do with that? And we can't combine it. They are not like terms. So I have C plus 160/9 equals 5/9 F. All right? We're going to divide both sides by 5/9. Now, in middle school, they taught you, and this is handy, when you divide by a fraction, you basically are just flipping the fraction and then you're multiplying now, right? So that's what I'm going to do. I'm going to show this, but what I'm really doing, I'm multiplying this entire side by 9/5. All right? So that actually, in the midst of this big mess, some parts of it get friendly because of that. I distribute here, so I get, I'm out of room here. Let me see if I have a piece of paper to continue writing on. So, the 9/5 distributes, I get 9/5 times C is 9/5 C. And when I multiply these two guys, 9/5 and 160/9, these guys cancel because 9 divided by 9 is 1. It's gone. I really end up with 160 over 5. The 9s are gone. And that is an easy reduction in the calculator. 160 divided by 5. It's 32. So you get from that crazy mess into a slightly less crazy mess. 9/5 C plus 32. That is my Fahrenheit equation. All right? That's plenty. You have almost 20 minutes in class, and you're going to get the homework assignment now. Okay, there's a little bit of both types of problems, okay? So good luck with it, and if you have questions about it, ask me on Friday. Okay, see you later.